Move into 8.3, I think, which is a continuation of what we've been doing. So you shouldn't have any problems. Should be it right there. Yeah. And this is just a continuation. Now, before they were using A, B, and C. Now we're using X, Y, and R. Okay, the reason they're using the R, where are you going to see the R again? Anybody know? Where are you going to see this R again? Physics. What kind of what does R represent?
Radons.
Okay, I heard distance, and what'd you say? Who said that? Somebody said it on Skype.
I said it. It's Jennifer.
Okay, what'd you say?
Radons.
Radon or radii? Radii?
Okay.
Well, yeah, but in physics, what do we deal with in physics? Starts with a V. The arrow. Vector. And what does the R stand for in vectors? The resultant vector. Okay? Usually, which is the hypotenuse of a 90-degree triangle, or the third side of a acute or a obtuse triangle. So what they're trying to get you to do is remember that R could be the radius of a circle, and they're getting you ready for physics where R is the resultant vector. R sine theta, R cosine theta, remember me showing you that? That's the resultant vector. So make sure you make these notes. It's not, like I told you, it's not like you have to reinvent the wheel. You're just changing the letters, and instead of calling X A, you're calling it X now. Some people like it that way. I do, preferably, but 90% of the time, if you're dealing with mathematics, you're dealing with what? X and what? Y. So most of the time, it makes sense. I'm not going to spend a lot of time on this because you already know it. Okay? So right quick, find the sine, cosine, and tangent of this function. Now this is where people get a little bit confused, especially when they've never had trigonometry. Put the little man on the angle. Now you can do it two different ways. Where can you put the little man? Give me two places you can put him. You can put him at B and you can put him at A. Is either one of them wrong? No. But pick one and stick to it. I'm going to pick A. So you're going to put the little man at A. I got to get my whiteboard up. In just a second. Oh, I thought I had it up. I guess I didn't. Must shut it off after the last class. Okay, any of the Skype people, if you get kicked out or if something doesn't work, just remove yourself and you should be able to pull me up. H. McClure, HMCCLURE at tctc.edu, and you should be able to add yourself back to the class. Does everybody understand that?
You can usually do it from the home page too. It'll say rejoin the class or whatnot.
Yeah. So if something happens, Mr. Storrs, you listening? I know you got kicked out a couple of times.
Yeah.
Okay. Just come back in and add it if you need to. Okay. So that way I don't lose you. If I do lose you, you can come back in.
Okay.
All right. So this guy, I'm going to put the little man on A. And this is what a lot of people forget. They can't understand where you're getting if you got two different angles. Well, just pick one. And if you put your man on A, that means his leg is on the hypotenuse, which is R, and the what? Adjacent, which is x. So that means he's looking at the opposite, which is y. So sine of theta is equal to, Oscar had, be what? 7 over 25. Cosine a hump, which would be 24 over 25. And tangent is equal to 7 over 24. Oscar had a hunk of apple. Is that right? 7 over 24? Now, if you want to find that angle, divide by the sine, then theta is equal to the inverse sine of 7 over 25. Theta is equal to the inverse cosine of 24 over 25. And theta is equal to the inverse tangent of 7 over 24. Somebody do one of these and tell me what this angle is right here. Make sure your calculator's in degree mode. Take the inverse sine of 7 over 25 and tell me what the degrees is. And you make sure it's in degree mode. I'm sorry, what? Mode. Go to mode. Make sure it's in degree mode. Okay. I thought it would be more like a 30. I'm sorry, what? 16.26. Now that sounds better. 16.26 degrees. Because if you had like 0 degrees right here, then 16, then that would make 24, 25. This 7 would be like 0.26 or something. It would be real small. So since this is a fraction of one of these, then it'd have to be like you'd have to have some degrees in it. And check it by doing one of these. And you should get the same answer. Now, what if you put your little man here? Well, now his foot is on the what? Is on the adjacent and the what? The hypotenuse. It's always on the adjacent and the hypotenuse. Now his opposite is here, which means that that's y. So now if you did it, you're going to come up with, well, 80 or 90 is going to be what? 106.26 from 180 is going to give you what? 180 is going to give you 73 point what? This is 73 degrees. 73 ... degrees. So if you did the sine Oscar had, well, the sine would be 24 over 25. So somebody take the inverse sine of 24 over 25 and tell me what you get. 73 point what? Which is that. So you can get your degrees 2 different ways. You can find this and then subtract, add this, so 90 and subtract from 180, because all triangles have 180 degrees. Or you can just do the inverse sine of 24 over 25, which would be 73.74. It's all where you put your little man. And what's confusing to students is some teachers don't tell you where to put the little man. And then why is it confusing? Because you don't know what? You don't know where theta is unless they put a little theta. But in this one, do they give you a theta? No. Okay, well, they tell you there. Yeah, they do. They do that. But most people look for the little theta. All right? Next question. Or anybody got a question there? Which they'll probably show us the answer. Yep. Here's your special angles. Golly, you already told us all this. Yep. Here's your special angles. Now, if you didn't write them down that day, you need to write them down today. There's your 30-degree angle, 60-degree angle, and your 45-degree angle. And there's your little chart. Now, I also told you to go ahead and pull this chart up. All you got to do is go to Google and pull up special angles. Just pull up special angles and hit images. And you should be able to print you out one and put it on an index card so you'll have it. Capiche? Cofunction identities, write these down. In a right triangle, ABC, with a right angle C, the acute angle, A and B, are complementary, meaning that these two, A and B, equal 90 degrees. Because that's 90 degrees. Okay, we already talked about that. So sine is equal to AC, which is equal to cosine of B. We've already talked about that. Okay? When did you talk about that, Hubert? Remember when I told you that you can get the same angle with the little man being here, but it's going to be a different angle here, but the cosine will be the same. That's what they're saying. It's all where you put your little man. It's a whole lot easier for students to grab on to, and you don't have to put the little man, but the little man always has his foot on the adjacent and the hypotenuse. If I just say just a sine theta, then you may not remember that the little man's foot is on the adjacent and the hypotenuse. So it's something to help you out, especially for those who've never seen trigonometry before. So make sure you know where to put the little man. If they say A, then you're going to put the little man here. If they say B, then you're going to put the little man here. And the directions will tell you, or they'll put a theta, and they'll say find the sine of theta. Something to that effect. All right, here's your cofunction identities. Now again, you can write them down now, or you can just print out that green sheet or one of those sheets on Google, however you want to do it. But we're going to be going over these today. So you might want to write at least the sine, cosine, and tangent down. And you'll see an example probably on the next slide where you like the sine of 52 degrees or whatever, and you got to subtract it. So we'll see. I'll take a picture of it. That way you'll have it. I actually probably do a screenshot and send it to everybody, but that's just extra work for me. You got them? Well, hurry up. How we doing, Skype people? We good?
All good. Just take a picture of it.
Moving on. We'll show you an example on the next page. There we go. Find the reference angle for each angle. cosine of 52 degrees, 16 minutes? Well, first of all, you might want to draw you a picture. Don't know if it'll do you any good or not, but I like to know what I'm looking at. "52 degrees is going to be somewhere right in there because 45 is right here, so 52 degrees is right in there. So 52 degrees, 16 minutes. So you probably got something that looks like that. So what could we do? Well, we could subtract it from 90. That would give us this angle right here. Maybe that might help us. So take your angle. I'm just going to bring it up on here. Same thing with pi tangent pi over 6. Just go ahead and plug it into your, there it is, 90 minus 52, 16, and there's your sine of 3744. Now, will the cosine of 52, 16 and the sine of 3744 give you the same angle? Yes. But what they're trying to get you to do is they're trying to get you to think in terms of sine and what? Cosine, Hubert. That's right, class. Because in identities, what is the number one rule of identities when you're rewriting identities? Always put in the terms of what? Sine and cosine. All right? So they're trying to get you to start thinking about sine and cosine, sine and cosine. That's the only reason. And they're trying to get you to, and you already subtracted. We know how to do that because it's complementary. Okay, pi over 6. Well, pi over 6, you could subtract that from pi or pi over 2, whichever one you want to, depending on where you think it is. Let's see. I always tell students to find what angle you're talking about before you actually get started when you're talking about pi over 6. So I tell students pi over 6 is equal to 180 over pi, which is equal to 180 divided by 6, which is what? 30 degrees. So this is basically the tangent of 30 degrees. But they're going to ask you to take it away from pi over 2 probably. Yep. See, pi over 2. How did I know to take it away from pi over 2? Because I know that it's not what? It doesn't go over 90 degrees. How do I know that? Because I always tell my students in Trig, when you're dealing with a radian, always turn it into a degree so you know where it is. Because a lot of people just like shooting from the hip. It doesn't work very well. Okay? Always know where it is, and that's why I did this right here. So I know that it's not over 90 degrees, so I can subtract it from pi over 2. Instead of, say, like subtracting from pi over 8 here, from pi, which is 180 degrees. Now here they're telling you to put in terms tangent in terms of cotangent. And what they're getting you ready for is getting you ready for rewriting those identities in section 2, I think, in unit 2. Questions? A reference angle for an angle theta written theta prime. Sometimes it's written theta prime, sometimes it's written as theta. Not theta, but theta. But you won't see that in here, I don't think. It's a positive acute angle made by the terminal side of theta and the x-axis. Find the reference angle for each angle. So 218 degrees. We know that 218 degrees is where? In the first, second, third, or fourth quadrant? Third quadrant. So we know it's less than 270. Now, if they were wanting with the y-axis, it would be 270 minus 280. But since they want it with the x-axis, it could be two different. It could be what? 218 from 360, or it can be 218 minus 180. Okay, a reference angle for angle written theta prime is the positive acute angle. Which one's acute? 180 from 218 or 360 minus 218? 180. So this one's going to be 280 minus 218 minus 180, which is 38 degrees. Somebody help me out. Check my math. Okay, thank you. I appreciate y'all checking me. Thank you. One person. Thank you for the interaction. Oh. 38 degrees. Now, what does that mean? That means that you've just done this. Now, 218 degrees is somewhere over here. That's 218 degrees, but I really don't want that. I want to know what this angle is right here, and that would be 180 from 218, which now we know that that angle is 38 degrees. Now, what's the only thing you have to remember? That your x is always going to be what? Negative, and your y is going to be what? Negative. You have to remember that. All students take calculus. So the tangent and the cotangent are what? In quadrant 3. Positive. Got to remember that because that's going to get you on the test. Whether it be a standardized test or whether it be in here. Comprende? All right, first of all, 5 pi over 6. What's the first thing you're going to do? Find out where the heck you are. So what is 5 pi over 6? Well, you go over here. 5 pi over 6 times 180 over pi. And let's see if we can cancel something out. Let's see, 3 will go in there 2 times. 3 will go in here, what, 60? And 2 will go in there 1 time. 2 will go in there 30. 30 times 5 is what? 150 degrees. So the first thing you do is draw your picture. 150 degrees is where? So, is this the acute angle or is this the acute angle? So this one's going to be what? 30 degrees, and you know that your x is always going to be what? And your y is always going to be positive. So therefore, all students, your sine and your cosecant is going to be positive. These are the little things in trig that people don't go over. The little things like finding where you are. Because if I just gave you 5 pi over 6 or 7 pi over 6 on the test and said find the reference angle, you'd probably freak out. The first thing you do with a radian is find out where it is. Because we don't think in terms of radian, we think in terms of what? Degrees. And it's going to be that way when you get to the real world. Yes, sir.
On the first problem, what was positive is tangent what? Positive for the third one?
All students take tangent and cotangent. If you haven't learned all students take calculus, you're going to hear it for the next 3 or 4 years. Because you're going to be in Calc 1, Calc 2, Calc 3, and Diff EQ. And you're going to hear it. Well, you're not going to hear it in Calc 3 and Diff EQ that much, but you'll hear it in Calc 1 and 2. All students take calculus. Oh, well, Hubert, I didn't learn that. I used... Shut up. I hate people like that. Oh, they're showing you how to do it right there. Pi over 6. I didn't do that. I just said 30, which is pi over 6. And you would take it away from pi because, I'm sorry, I forgot to do that part. Because we took it away from 180, you would take it away from pi. And pi is what? 6 pi over 6? Yeah, it's 180, but as far as a fraction, it would be 6 pi over 6. And 6 pi over 6 minus 5 pi over 6 is 1 pi over 6. So make sure you make that note, especially those of you that suck at fractions. Make sure you change this to 6 pi over 6. Okay? I'm sorry, what? Like that? I'm sorry. Yeah, I'll tell you what. We can do this. Let me go back. And take this out. There we go. And then we'll change this to white. And then I'll do this. And then we'll change it to 6 pi over 6. How's that? That better? I just want to impress y'all. I can't walk because I broke my toe. I didn't break my toe. I think I jammed it. You know when you kick something and it don't move? Okay, well, my big toe is black and it's big. So, it was on the farm. I was running away from a wasp nest. And for the others of you who don't know what a wasp nest is, W-A-S-T, nest, N-E-S-T, it's a wasp nest. Okay? Wasp. Clams on wasp. Well, it's not black, it's blue. Dark blue, like a bruise. Luckily, I didn't have to come to school. It happened Saturday. So I was knocked out Saturday. I couldn't hardly walk Saturday. And, well, it numbed up a little bit. But Sunday, I wasn't on it. I kept it elevated. Monday, we didn't have school, so I kept it elevated. Tuesday, I kept it elevated. And those 3 days really helped because the swelling went down. But it's hard for me to get around right now. What I should have done is I should have took 2 weeks off, made y'all get a substitute, did workman's comp, and also got me a, what do you call them things, handicap stick. That's what I should have done. So I thought right up front up here.
You know, you said I like your joke, but I had
I know.
actually do that.
I know.
He broke his toe.
I know. I'm just being facetious. I don't suck like that. All right, here we go. All right, y'all do this one. If you can't do it, just consider yourself what? A failure. Find the trigonometry, just find sine, cosine, and tangent. I know y'all know how to flip something over. Okay, just find the sine, cosine, and tangent. Find the values of the trigonometric function for 210 degrees. Gosh, Irma kicked up it looks like an old Indian canoe. Did y'all see that on Facebook? Yeah, it's a cypress canoe. Came out of the Indian River. It looks like it was, they don't know how old it is yet, but I don't know, see. I guess it's Native American times. They don't say when it was. Probably 1800s. That's what it says. I don't know. Ain't that neat? You have to see the. It looks like a log, only it's got a dugout portion and seats in it. So I don't know if y'all know what it looks like, but it's on Facebook. I don't know if it's on y'all's Facebook or not, but I just thought that was interesting. Y'all bought Hillary's new book? You know, I'm about like one of the newscasters says, why don't she just go away? I mean, my God, it's been a year, almost a year, hasn't it been? Yeah, I posted that yesterday. Yeah. Yeah, she can't remember anything under oath, but she can remember enough to write a 500-page book. Now, some people can't read sarcasm.
Over text, it's a little different.
Huh?
Over text, it's a little different.
Well, it's not
You're like
text.
excessive.
I was responding to a picture of Nancy Pelosi, and I said, "Go Nancy. I hope she stays in charge of the Democratic Party. She is doing a great job." And then I put under it, I put hashtag Make America Great Again and hashtag I love my president. Okay? So what am I saying there?
You're not being serious.
I'm not being serious. This guy comes up and you crazy. You're an idiot. Read the hashtags, dummy. Huh? No, what do they say? Yeah, it pretty much, yeah. Oh, have y'all seen the very pretty eyes, the picture with the pretty eyes? Well, I'll show it by the end of class. I don't want anybody fussing. Miss Simmons will fuss and complain. She'll complain to my department head that I'm not talking about math. Right, Miss Simmons? She's probably asleep. All right, so 210 degrees. 210 degrees is over in here. So that means we need this acute angle right here. So it's going to be 180 from what? 210 degrees minus 180 is equal to 30. So this is a 30-degree angle. That means we're going to have a negative and a negative. So that means all students take calculus. So that means the tangent and the cotangent are what? And that's going to be, they don't give us any numbers, do they? No. So we know that sine is going to be negative, cosine is going to be negative, tangent is going to be positive, and of course cotangent is going to be positive, and the secant and the cosecant are both going to be negative. Now I don't know what they want. I don't know if they want negative x over negative y. I don't know what they want, but I just want you to be able to locate your angle. Okay, they're using the special angles. Okay, that's fine. I didn't know if you can use special angles, but you see, What do you notice about what I said about the positives and negatives? Everything's negative except for what? You've got to remember that. I didn't know they wanted us to use special angles. That's fine. Next. This is just some finding trigonometric functions using non-quadrangle angles. I think that's just, instead of 180, they're talking about 360. You know, the spirals where you go round and round and round, which you don't see in real life anyway, but that's what they're talking about here. Okay, now this one right here, is this one difficult, or you just got to read? You just got to read. All right, negative 240, so that means we're not going in a counterclockwise position. We're going what? In a clockwise position, find that angle. This one is one of those spirals, so you got to find that one. All right, so do those two right quick. So, Georgia played Notre Dame pretty good, barely pulled it out. South Carolina did good. Clemson did good, but that was a defensive game. It always is a defensive game you've been to. And Alabama played Dorman High School. So, everybody won this weekend. So who does Clemson have this next week? Who? Louisville. That'll be a pretty good game. And who does South Carolina play? Anybody know? No. Georgia and South Carolina both are trying to rebuild, so I'm not going to say who's going to win that game. Depends on how bad Kentucky sucks. Who's Georgia play? Anybody know? You don't think they do? And who does Alabama play? Alabama probably got to play SEC, so they probably got somebody tough. Who they playing a cupcake team? Well, I still say they deserve it after playing Florida State their first game. That took a lot of brass to do that. And Florida State, huh? Yeah, but they had a hard time up to 3.5 quarters. Florida State did pretty good. Oh yeah, they won't have a problem there. Who? Out in California? Stanford. Is that like Dorman High School?
It might be small.
Why do these teams play these cupcakes? Why don't they just do a scrimmage before football season starts, and then that way they can play their real teams? I can't stand this. You are a man. I can't stand when they play these cupcake teams, especially when they're supposed to be decent. All right, so here we go. 240 degrees negative. Well, there's negative 90. There's negative 180. 240 would be somewhere in here. So, to get this acute angle, which is this is the one we want right here, we got to subtract 180 from 240. Do we care about the negative? No. Why do we not care about the negative? Because the negative just tells us what? Direction. Just in mathematics. It tells us direction. That's it. After we find out the direction, we don't need the negative anymore. So, we want to find this angle, so it's going to be 240 minus what? 180, Hubert. That's right, class. So, 240 minus 180 is what? Dang old 60 degrees. So that's 60 degrees. So this time you would use your, find the exact value of each expression of the cosine. So we're going to find the cosine. So let's do our 60 degree. And remember, we got 2 or 3. 1, 2, square root of 3. Or is it 1, 3, square root of 2? Which one is it? 1, 2, 1, 2, square root of 3. That's it. Right? Anyway. So we got 1 here. What's bigger? 2 or the square root of 3? 2 and the square root of 3. Make sure I did that right. Sometimes I transpose the 2 and the 3. It's that medicine tape. Okay, so here's our little man. Because our little man is right here, because that's where our theta is. Oscar had a hump 1 over 2. So 1/2 should be right. Now I didn't memorize a that blame thing there, did I? I didn't memorize a chart. I didn't memorize anything. I just did it because I learned it. That's the secret to trig and calculus. But if you suck at algebra, you're going to suck at calculus. So. What'd they get? Look there. Now I forgot the negative. Of course, the negative goes out front because it's telling us that it's the negative direction. So I forgot that. And I also forgot my x is what? Negative. I forgot that too. So I suck. Negative. I should quit school. All right, now do you do 625 to 75 degrees? I'll go to the next page without one. No, we won't do that. So what is 360 times 2? 720 degrees, Hubert. Yeah. So you can't use 720 degrees because that's too much. So you're going to have to subtract 360. So 675 degrees. Minus 360. Dang old 5, dang old 1. Dang old 315 degrees. Somewhere in here. So the acute angle is where? Right here, Hubert. That's right, class. So to get that angle, I got to take 315 and subtract what? Well, 360 minus, yeah, I'm sorry, 360. Should be 45 degrees, shouldn't it? Now, this is 45 degrees. So, 45 degrees is going to be like this. 1, square root of 2. But the 1 is positive, but the negative 1 here, the 1 here, the y is what? Negative. Or you could say all students take calculus, so the tangent is going to be what? It's negative. So you can either do it this way, all students take calculus, or you can say, okay, I'm not going to worry about all students take calculus. I'm just going to do Oscar had a hump of apple, which would be of apple which would be negative 1 over 1, which is negative 1. Oscar had a hump of apple. So hopefully you can see where students get confused with trig. It's all how you go about doing it. And I hate to say it like that. It's not like algebra. Algebra, you can kind of, with equations and stuff like that, you can pick your way through it somehow. With trig, if you don't have a methodical way of doing things, you're going to suck at it. And when you're talking about finding these angles, first thing you got to do is find out where you are. It's kind of like when you're lost. Do you build a fire first, or are you trying to figure out where you are first? You're trying to figure out where you are first. Which way is north, which way is south, which way is east, which way is west, which way the water's flowing. That kind of stuff you find out first. Then you build a fire. Okay? Next. Oh, we got to go through and see if we're right. Did I get it? Did I get it right? Oh well, I don't know if we got it right or not. Which way? Go back. Oh well. Approximate the value. Now this one, approximate means you're going to use what? A calculator. So you can just punch these in. I'll put some of these on the test, but if you miss them, you don't what? You don't tell anybody. Okay? Did you get number 9 right? Did you do it with calc? Yeah, I got it right. Yeah. Don't tell anybody I got these wrong. Because then you'll hang a sign around your neck that says, I'm a failure. Now, how will you find the cosecant? Well, what is the cosecant? 1 over the what? Sine. So find the sine and just do 1 over. That's probably what, I don't know how they show you to do it, but they should just show you how to punch it in the calculator. Yeah. See? See the 1 over sine? That's how you do the cosecant. Okay, if I give y'all 20 questions on this Unit 1 test, this is one question. I'm not going to give you a lot of these because, I'm sorry, I could teach my 10-year-old, 11-year-old son how to do this. There's no brain power on this. I know that's what y'all are used to in K through 12, but we don't do that here. When I go across a bridge that's built by one of my students, I don't want it to fall down. Okay? I'm not going to spend a lot of time on this because you should know how to do this and you've got to do it. Okay, now these are the questions right here that get students confused. Now, if you followed what I've talked about, then you shouldn't be confused. Read the directions. It says find all values of theta if theta is in the interval from 0 to what? Okay, so that means that all quadrants are in effect, right? They want to know where the cosine of theta is equal to negative square root of 2 over 2. Now, before you even start, I want you to figure out where this is. There you go. That's one way to do it. She's using all students take calculus. All right, what's another way to do it? Well, what is cosine? A hump, Hubert. That's right. And which one cannot be positive or negative? The hump, the hypotenuse. So you know that 2 right there is not negative. So the negative is in the square root of 2. So that means Oscar had a hump. That means the adjacent is what? Negative. So therefore you know this negative x and it's positive, probably positive what? Well, let's see. All students take cal. Yeah. It's going to be in the second quadrant. Now, what about the third quadrant? It could be in the third quadrant, but what's the problem with the third quadrant? The x is what? The x is negative. In the third quadrant, the x is what? Positive. So it has to be in what quadrant? It's probably in the second quadrant. Yeah, I'm sorry, third quadrant. I was talking about the fourth quadrant. The fourth quadrant, it won't be because, I'm sorry, it could be in the second or the third quadrant. I'm sorry. So those are the two angles right there. I was thinking of the fourth quadrant when I said that. X is positive in the fourth quadrant, so you can't have it. You can either have it in the second or third quadrant, or you can say all students take calculus. Okay, you know that the cosine is positive here, so it's not there, and it's not here, so it has to be here or what? Here or here. And that's basically what they're saying. They didn't do all students take calculus. What they did is this. Cosine of theta is equal to, Oscar had 800. Okay, so that means we got a 2 on the bottom, so it's positive. So that means A is negative. So negative square root of 2 over 2. So that means we've got a triangle with a x of negative. So that means this way. And that means we also have a hypotenuse here and a hypotenuse here. And therefore, that's the two angles that it could be. That's what they're saying. All right. So you can do it, all students take calculus, or you can do it this way. Again, if you don't know those two methods, USOL, you don't know what the heck they're talking about. This is no joke. I remember being in Trig and not having any clue what this sentence made, this sentence was saying. I had no clue. Why? Because I was never taught to learn Trig. I was always taught to memorize. And it didn't do me any good when I got to this because I had no idea what it was saying. Capiche?
So how do they get
I didn't notice that.
It's down, it's on the solution.
Oh, right here. Okay. Since the absolute value of cosine is equal to this, which we don't have that, we have the cosine is equal to negative. They're finding the angle, and then they're saying it could be in the second or the third quadrant. That's what they're saying. You see what I'm saying? Mm-hmm. All right, take the square root of 2 over 2 in your calculator and hit inverse sine, cosine. They're ignoring the negative, okay? Mm-hmm. Because you're trying to find the angle. You're trying to find the special angle. So take the square root of 2 over 2 and take the inverse sine of it. Huh? Oh, what kind of calculator you got? Okay, you just here, let me show you. Let me get out of this right quick. Pull up my handy dandy virtual calculator. They're just being generic and they're saying, okay, I got square root of 2 over 2. So I'm going to get second inverse cosine, the square root. So I'm on square root of 2. I'm sorry. Square root of 2 divided by. I better not do that. I better put a parenthesis right here. Divided by 2. And enter. And make sure you're. Sorry. Clear. Second entry. Enter. There you go. And then they're just finding the angle, and then you apply it to all students take calculus. And which one is that? That's the second and third quadrant.
And we had another step.
Okay, let's see what that is.
So they're just finding the angle squares.
Yeah.
to different plots.
Yeah, 45 from 180 and 45 plus 180. I didn't notice the little thing with that. That's it. Question. Great. Complaint. Okay. Now, what section are we on? This is 8.3 or 8.4?
That was 8.3.
Okay, 8.4 is next, and then 8.5. So we're maybe talking about a test, not the next week, not this next week coming up, but the next week, probably middle of the next week, not this week coming up. When's the 19th? What day are we on? When's the 19th? Next Tuesday. So we're close. We're a little bit over, but that's normal. I go slower than most of your other teachers. Okay? So let me, okay. Skype people, y'all got any questions? They're all asleep.
All good.
Oh, Mr. Crittenden's not asleep. The rest of them are. Right?
No questions.
Okay, Miss Fuller's not asleep.
No
No
questions.
Okay, no questions. Just Miss Simmons is asleep. All right. So now y'all work on 8.1, 8.2, and 8.3, and then we'll cover 8.4 when y'all come back. Send questions if you need them. Y'all
Yes,
have
sir.
a good one.
Yes, sir. You too.